Hello, folks. Hopefully it's live now. So I'll just cover really quickly what I just covered. Apparently you got to click a bunch of buttons to make this work sometimes. So anyway, thank you for everyone's for your patience. This is a bit of a technical new thing I'm doing. I've long broadcast my streams to the class, but I'm trying to do it to the whole world so anyone can watch. So we're going to be covering Python coding today. And let's see, let's make sure I can actually be seen here. Oh yeah, great. I can see me myself on the live stream. Wonderful, great. Okay, so what we're going to be doing today, it's going to be a very basic Python tutorial, okay? What you want to do is you want to go to this website right here, okay? I'm going to follow along, Colab, 1L, colab.research.google.com, and that's what we're going to be coding on today. Very basic stuff for about an hour, okay? Already running a little bit behind, but go to that website. I'll try to keep that website up so we can, when you do, you should see something like this. And what I'm going to do is I'm going to hit File, I'm going to say new notebook in Drive, okay? Well, maybe not new notebook in Drive. It's new notebook. Oh my goodness. See what fix. Oh, there you go. There. Fantastic. We're up and running. Little bit of a code, little hiccups there, little hiccups here and there. And when you make a new notebook, it looks something like this, okay? And this is where you will type your code. And you can also type comments, okay? And right up in the top is your title. And this stands for a Python notebook, okay? PY notebook. And so let's just call it, my notebook, okay? So one of the first things you do in any programming language, does anyone know what you do? You want to print something. I think people in the Zoom chat might have a head start on this as to answering this question. It's a classic thing. You want it to print. You say print hello world. You want it to have it say hello world to the screen. So the way you do this in Python is you type the word print with an open parenthesis, and inside you will put in quotes and the thing you want to print if that thing is text. So if that thing is in text, you put it in quotes and you say hello world with an exclamation point because it is excited to exist in this world. Wonderful. So all you got to do is click this little, in order to run this line of code, you click this little arrow button here. Okay. All right. All right. Hello world. Yes. Got a question in the chat. Are we using Zoom for the class as well? Yes, we are using Zoom for the class as well. You can use YouTube or Zoom. I reckon for the class, you use Zoom just because it's going to be more responsive than YouTube. I can see the YouTube comments, but they come in a bit with a delay. So, all right, look, hello world. We did it. We did it. Okay. We printed hello world. We're coding. Once you can do hello world, you can do almost anything. And again, you're at colab.research.google.com right here. Now, you can do more than just print words. You can also print the result of math and numbers. So for instance, you can create another line of code. So I click right here and I hit enter. And I want to say, I want to print the result of 1 plus 1, which mathematicians will tell you is 2. So if I say 1 plus 1, okay, it should print the number 2 after hello world. And boom, you click go, and in fact prints. I don't want to run the cell. Go away, please. All right. All right. Therefore, you can print that. It's great for checking if your code's running correctly, that you print out something you want to do, right? And of course, a quintessential thing in programming is you want to create variables. So let's say instead of printing math directly, we want to say that x equals 3. We have a variable called x, and we want to assign it to be the number 3. So we say x equals 3. And then after that, you say print x. And it's going to print the value of x, not the letter of x, which is 3, because x is not in quotes. Okay? X is not in quotes, and that's why. So that's it. That's a lot of that's not all of Python, right? So that's great. Now, of course, you can assign other variables. Now you can say, hey, I want y equal to x plus 4. So mathematicians will tell you that that is 7. And I'm going to say, hey, I want to print y, the value of y. So when I run this code, it now prints the value of 3 plus 4, which is 7, okay, because it's printing y. All right. So that's, again, really rudimentary. We're starting off at the very beginning, right? So you can assign, and the beautiful thing about Python is that unlike a lot of compiled languages where you have to tell the programming language beforehand that this is a number x, it already figures out it's a number and it's 3. And that's like an integer specifically. Whereas in C++, you have to declare it as a floating point value before you ever want to use it, meaning you want it to have a decimal point with numbers thereafter. Python handles that all behind the scenes. It makes it very easy, okay? All right, because you can also have different kinds of variables. So Z here is a variable, and let's say we want it to be the word hello, okay? And then I can print Z. And I can run the code, and it prints Z and it says hello. Actually, we'll have it say hello again, right? Because Z is now a different kind of variable. It's what we call a string of characters or a string, okay? So that easy in Python, all right? For those of you who have used MATLAB before, MATLAB has a lot of that similar convenience involved. Now, there are some commands in Python that are easier in MATLAB. We'll probably encounter a few as we move forward. Because today, you might say, hey, how much of Python are we learning? And that's a good question. I'm glad you asked it. What I would like to do is learn enough of Python that we can make a very rudimentary version of this game right here, okay? It's called Gorillas, okay? And it's a game where you have two gorillas, and their job is to throw a banana at each other. And when it does, it hits the gorilla, and you win, okay? Look, we're not going to get to the point where we're drawing a bunch of graphics, okay? We'll probably just have some very simple lines being drawn for trajectories. And you take turns, you know, putting in speed and angle and try to throw it at the other gorilla. That's what we're going to try to do today, all right? That's where I want to get to. But it all starts humbly with hello world, okay? All right. Now, here's the other thing you got to know about Python is that, or any programming language, you want to write comments to say what you're doing. Okay, if your code doesn't have any comments, it can be hard to explain. All right, the way you write a comment is you put a little hashtag. Okay, all right, and you say this is a comment, and this allows you to describe what's happening in the code without it actually being code. So in Python, you want to use the number symbol, little hashtag. Okay, all right, there you go. So this is a comment that didn't affect anything, but you can use it to say, hey, I want to say this prints hello world. Okay. You don't have to comment every line of code necessarily. There are different philosophies for how much you comment. It depends on what it's for, but I highly recommend commenting your code somewhat so you know what's going on. Or I am grading your work for a class. I want to know what's going on. I'm pretty good at interpreting people's code, but it's helpful to have comments. So here we go. We have this very simple piece of code. Now, another really important function in any code programming language is looping. Okay. All right. So often you want in programming to do something over and over and over again. And there are lots of different kinds of loops. There are something called for loops and while loops or do while loops. Okay. But the one we're going to be using the most today is something called a for loop. Okay. And of course, the for loop, its job is to just go through a fixed number of things. You want to say, hey, I want to print out the word hello world 10 times. And a way to do that, one way to do that is just by copying print hello world, print hello world, print hello world, print hello world over and over again. And it will do it, but it's a pain in the butt if you want to do it a bunch of times, right? So you instead can loop it in what we call a for loop. So let's write a for loop. A for loop is you say for, and then you create then you list a variable. A lot of people will use I for a for loop. This is the number of times you're going to go through the for loop, or some would say iterations, hence the I, okay? So you would say, hey, for I, you want to count through a certain number of loops. And the way you do that in Python, at least a very common way, is you want to say, hey, for every I that's in a certain range, let's just say 1, 2, 3, 4, 5. Okay, right? We want to do it. So we wanted to do it count up to 1 to 2 to 3 to 4 to 5. Okay. And so we're going to say in range. And in order to find the range, we're going to do an open parenthesis. You'll notice we'll do a lot of open parenthesis right here. So we'll say 1, 2, 5. Okay. And then what we're going to do, and then you put a little colon there. So this is the colon, all right? That colon, when you hit enter now, you'll notice there's a little indentation there that comes in automatically. Unlike in MATLAB, people who use MATLAB, the indentations matter in Python. Okay, in MATLAB, that white space, we call it, that empty space, doesn't matter. In Python, it totally does. And so this colon indicates there's going to be a new indentation. Okay, so what we're going to do is we're going to say, hey, let's print the value of I. Okay, as it's moving through the loop, and we'll see what happens. Let's run the code. All right, so it prints 1, 2, 3, 4. What? Where's 5? Interesting. The first twist of Python, for those who've never coded in it before, emerges, okay? You see, the way that Python likes to count is it doesn't start counting at 1. It starts counting at the number 0, okay? So the way this range command works is to say, okay, I'll start at the number 1, then I'll go up to 2, 3, 4, then I'll end at 5. So if I want to count 1, 2, 3, 4, 5, I would go 1, 6, and run it again, and go 1, 2, 3, 4, 5. Or what is more common is that if you want to count through 5 things, is you say range 0 to 5, okay? Now, this might seem a little silly, okay? But here's the thing, it loops through the first iteration, it starts at the number 0. It prints 0. Then it loops again. Then the number 1, 2, 3, 4. That's 5 different iterations, right? So if we wanted to print hello world 5 times, we just put hello world in there, and we run it, and it prints hello world 5 more times. It's printing it up there too. Let's put a little separator in there. So say, hey, let's print something else. Let's say print, open parenthesis, then a quote, then a double quote. Let's put some dashed lines in there so we know how many we're printing after the dashed line. And look, print, open parenthesis, that, voila. Okay? All right, 5 hello worlds. If you want 10 hello worlds, we just say 0, 10. Simple as that. Not a very hardcore programming example, is it, right? Nothing too crazy here. All right? So this is most of the looping that we will be doing in the class is going to be doing some for loops, the occasional while loops, not too different, okay? So we have a hello world. We have the ability to do a loop, a for loop here. Now, this is all right, okay? Let's start trying to do something fun. Let's start trying to actually make this game. And what we would need to do, we actually are not too far away from knowing all the things we need to do to make this game called Gorillas in a very, very rudimentary way, okay? So I'm going to go back to my iPad here, okay? And I'm going to say, what do we need for Gorillas? At a bare minimum to play. Gorillas. Okay. The app name. Is it a question for app name? This is we're using. So if we want to know, so we research. This is what you want to go to. This website right here. Okay. All right. That's the website you want to go to. All right. So what do we need to play Gorillas? So we need an ability to draw the scene. I'm going to do a very simple drawing of the scene, meaning that what I want to do is I want to have a little box. I want to be able to maybe just draw the trajectory of the banana. Oh, look, there's the banana right there. Ooh, it's going to go and it's going to hit some gorilla. And right now our gorillas will be dots. We're going to keep this simple. If you get the basic functionality, you can make it look more complicated later, right? So what we need to be able to do to draw the scene, what we're going to use are plots, or plotting, okay? Or graphing, as it might be colloquially known, right? So we got to do some plotting, right? We're also going to need to be plotting a lot of different points. So we're going to be plotting a whole bunch of points in what we call an array, okay? And so we're going to use is what we need something called arrays. And the kind of arrays we're going to be using are in a package called NumPy or numerical Python. Okay, this is quintessential, a quintessential package for how you basically we're going to use commands in this package to be able to create arrays, and arrays are just lists of numbers. You have to have those. All right, so we're going to use a few packages, one of which is called NumPy, which we basically tells Python, hey, here is all the code you need to know how to use arrays. All right, and also for those in the class, we're also talking about linear algebra. It'll do things like matrices and vectors and multiplication of those vectors. Okay, so NumPy does all of that for you. So if you are a fan of MATLAB, known as the Matrix Laboratory, if you want all of that capability, you want to include NumPy, and we'll show you how to do that. Okay, and for plotting, we have to give it another library. It's called matplotlib, or the plotting library. Okay, all right. So we're going to use those two packages, and that's most of what we need. And we also, if it's a game, that means we also got to get like an input from the user, from the player, right? We need inputs from the player. And we also have to be able to know that when we have these inputs from the player, which might be things like the angle and the trajectory, sorry, so angular and speed, the angle and speed of the banana, that's what we'll ask them. That's what will tell you where it goes. There's another game that's a lot like this. It's called Worms. I think that I'm not sure if that's if that's an active game anymore. It's very similar to Gorillas, but it's a lot more complicated. But it clearly is inspired by Gorillas. Okay, the angle and speed of because you have to ask it for the angle and speed of the banana, right? And once you have that angle and speed of the banana, we have to do all the math to draw the trajectory. Okay, that's the key. Those are the things we're going to try to get through today in about 35 minutes. I think it's very doable. All right, so let's go back to our code here. Okay, so here's our old code. All right, this is just a basic MyPython notebook. So we're going to try to make a new Python notebook. Let's see, new notebook in Drive. I think this makes it in your Google Drive. Okay, so this will show up in your Google Drive, so you always have it. Okay, so I created a new Python notebook. I'm going to call it gorillas.python notebook. Okay, and I'm going to create some text at the top. This is good practice to be able to tell your audience or whoever's reading this what this is about, or even yourself, in case you come back to this notebook years from now. Okay, so we're going to say this is going to be, let's see, double click to add. It told me to double click in order to change the text. I can say Gorillas game code. You often want to put your own name on your work, so Christian Hubicki and my friends. That's all of you, Christian Hubicki et al. Okay, you want to put the date, 2026. Today is the 14th of January of the Common Era. Okay, all right. So we're going to create the Gorillas game. So one thing we're going to need to be able to do, as we talked about up here, is we have to be able to plot, and we have to do these arrays of numbers. So we're going to start with these arrays of numbers. That's important. So we're going to tell Python we need this thing called NumPy. And the way that you tell NumPy, Python, that you want NumPy in your code, you say import NumPy. Okay, and that's normally enough. You say, hey, import NumPy. That's it. And what that'll allow you to do is then say, hey, I want to use a NumPy command. I want to use a NumPy to multiply two arrays together. So you would say NumPy dot multiply. But the thing is, typing in NumPy over and over and over again is a pain in the tush. Okay, so what we say is actually call it something simpler. Call it NP, let's say. All right. So that way, if we ever want to use a NumPy command, we can just say np.multiply. Okay. Saves us some carpal tunnel. All right. And that's just general practice. So we're importing NumPy as np. And here's what I'm going to do. I'm going to just leave this as the only command in this little block of code. So far, I've just been adding enter, 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 write more code. But in a Python notebook, one thing you can do is you can see how it says add code here. Okay. Just click code and it creates a new block. Why would you want to do that? Well, maybe you don't want to run everything with this run all command every time you want to make a change. Like we know that we only need that once we import NumPy as np once. So once we click that, we import it one time. Okay, it's imported. We don't have to import that every time that we try something new. It wastes a little bit of time, not that much time, but imagine you did a whole bunch of stuff, a whole bunch of code up high. Up in your code, and the stuff at the end you want to change. Well, only run that stuff at the end, again and again and again. Saves you time, saves you headaches, etc. Okay, so you can import NumPy as np. All right, and what you can use NumPy for is creating what we call arrays. So let's say we want to make an array, and again, it's just a list of numbers. Okay, so particularly a NumPy array. There are other kinds of arrays. We'll deal with that later. So let's create an array called x. And in order to assign x, we say x dot np. We want to create a new array, so we say np dot array. Okay, this is going to create an array, but an array of what? All right, so this is so basically it says, all right, in order to tell it, you have to create an open and close parenthesis, and you want to tell it the array that you want. And the easiest way is just to list out the numbers that you want. Let's just say 1, 2, 3. So we're going to create open square brackets. We're going to say 1, comma, 2, comma, 3. Okay. So you separate them by commas. Again, different from MATLAB. In MATLAB, you can get away with just spaces, right? Here, you have to use commas when you're setting these things up. It's just how it is. And this will create a list of numbers, just 1 with a 2, then a 2, then a 3, one after the other, left to right. Okay, and we can even print it to show you. We could say print x, and we can run this little bit of code, and boom, 1, 2, 3. Everyone following along? Zoom, you following along? You still awake? Good, thank you. They're up. My students are up late. Again, this is optional. You can follow it later, right? Okay, so we got that. np.array, print x. We're good. Okay, gonna take a sip of my beverage. Great. So we can create arrays like this. Now, you can also do math on these arrays. And sometimes you might say, hey, I have this big array of numbers, but I want to know what's in this third number. What's in there? It's stored somewhere. It's stored, but what is it? So let's make a quick change. Let's change these numbers into random numbers or just arbitrary numbers. We'll take 7, 8, 50. Okay. All right. So I reran the code. So now the array is 7, 8, 50, right? But let's say I want to access what that third element is. Okay. So what you do is you would say, hey, you would say X, hey, friend, I want to know what the third element is. And you might say, oh, you know what? Let's do the second element, just for sake of argument. I want to know what that second element is. And you might say, hey, okay, X, square bracket, what's the second number? And I'm going to print it just so I know what it is. You think the second number is 8. All right, and we're going to run the code. 50. That's not the second number. And here's why. I mentioned before that Python starts counting at zeros. It's a very computer science way of looking at the world. Normal people learn to count on their fingers 1, 2, 3. Computer scientists start at 0. So if you want the very, very first element of what we call this element, this is element 1, this is element 2, element 3. If you want the very first one, you say, hey, I want the 0th one. This is the first twist of Python if you haven't coded in a language like this before. But if you coded in many languages, you already know this. This is not a terrible surprise, but it's a surprise to some folks, right? So I clicked go, x0, the 0th element is 7, right? If I want to get the second element, I say I want element number 1, okay? If I want the third element, I say I want element 2. Okay. And if I said I want element 3, error, index error. So this process I'm talking about where I am looking inside of an array, this list, and I say, I want this one, that's called indexing. So it says index error, you indexed wrong, okay? Index 3 is out of bounds, okay? Yeah, it makes sense. It can only go 0, 1, and 2. You give it a 3, it's not gonna know what to do. Makes sense? All right, why does it print question? Why does it print the brackets? So that's a question from the Zoom. Why does it print out the brackets? I think that's just to show you that it's a vector, right? You as a mechanical engineer learned about MATLAB. When MATLAB prints out a vector, puts it in square brackets because it's a vector. So here I'm calling it an array. You can actually think of it as a mathematical vector for all intents and purposes. Okay. All right. Cool. Good question. Pop any more questions around. I can see. All right, a question. I wonder. All right. So okay. Let's. So we can now make an array just by listing out the numbers. Okay, 1, 2, 3, 4, 5, 6, etc. Right. All right. Do I see a question in the chat? See a question? I thought I saw a question with the hand up. I am still streaming. Looks like I might have any drop frames. No, we're good. Okay, so yes, so that's what we'll show next, which is how to make an array a different way. Because imagine you want to make an array with 100 zeros. Typing it out stinks. If there's ever a time where you have to type out lots of things tediously, you're probably doing it in a non-optimal way. There's probably a better way to do it. Okay. All right, so one easy way to make an array of a certain size is just to fill it with zeros. So here's what we're going to do. We're going to create a new code block after we change this back to, let's change this back to 0. Let's run it. Okay, so now that runs. So make a new code block so we can run it differently. So this is going to be about making an array of a desired size automatically, faster, automatically, without typing it out. Common thing you want to do when you want to make a new array is you want to make it the proper size that you want first with just arbitrary numbers and then fill it in later. It's called pre-allocating, okay? It's called pre-allocating, meaning you are giving it a certain amount of space beforehand, pre-allocate, all right? So let's make a new variable, let's call it y. Now let's just say we want it to be 100 zeros all in a row, but just one row, okay? You would say y is equal to np dot zeros, okay? And then open close, because this is what we call a function. It needs inputs, and that's where you put the inputs inside of that, those little parentheses right there, okay? And we want 100. We want one row with 100 zeros. So what we would do is create another set of parentheses inside. We want one row, comma, 100 zeros. Okay, 100 is going to be a lot to put on the screen, and we'll do it anyway. And then we're going to say, hey, print y. Okay, we'll explain some of this context later as to why we do that. All right, we're going to run it, and voila, we printed, and that's 100 zeros, all in a row. Okay, and our Zoom question, hey, why are there these brackets? We'll talk about that in just a minute, actually. Okay, I think there's a real good reason that becomes pretty clear right now. All right, so 1 with 100 zeros. Boom. All right. First off, why didn't we just say 100? Let's try 100 and see what happens. Oh, it's fine. It worked out fine. You can just do 100. That's 100 zeros all in a row. Okay? Or you could do 1, comma 100. And it does this. And the only difference is you'll notice that, hey, look, it now prints out 2 brackets as opposed to, what did I screw up? Oh, no, so 100. Here you go. 100, right? Goes to 1 bracket when you just do the 100, right? Okay. This 100, that's the easy way to do the list. All right. If I do 1, comma 100, what this is doing, it's not creating just a single row. It's creating a block of numbers called a matrix, okay? In this case, it's a matrix with just one row of a bunch of zeros, okay? But you could theoretically have 2 rows of a bunch of zeros. So let's do 2, 100. And here, look, 2 rows of 100 zeros. And a lot of math, you would use these matrices to do a lot of cool and fast calculations, especially in machine learning, which is nominally what this is for this course. Okay. All right. So here we go. So we can now pre-allocate a bunch of zeros. I believe you can also do ones. It's a little late, so I'm going to be a little frazzled. So let's see if this actually works. Ones. Yes. I just changed the command to ones instead of zeros. I just double clicked to create, this whole thing to highlight it, and I said ones. And I reran it, boom, right? So much simpler. So the reason the brackets are important is notice that when I'm doing 2 rows of ones, there's one set of brackets there, one set of brackets there, and then an outer set of brackets for the whole thing, indicating it's a matrix. That's a little more complicated than we need to get into today, but that's a little bit of preview for my class. Okay, so we can do, let's go back to having zeros, and let's just have 100 of them. Okay, and we're gonna print it out. Great. So we can make that, right, perfect. Now, what if I want all of those numbers to be different? I want to automatically make them count up. 0, 1, 2, 3, 4, up to 100, okay? There are a couple ways to do that. Right now, we're going to do it using the tools we talked about already, using a for loop. We're going to loop through each of those elements, 1, 2, 3, 4, 5, up through 100, and say each of those elements should be this, that, or the other thing, okay? So we're going to create a loop. To count from 1 to 100 in the array, okay? So what we need to do is make a loop. So we're going to say for, and we're going to I, this little iterating variable I, is in the range. So we want to count from up to 100. We would say 0 to 100, and it'll count from 0, 1, 2, 3, 4, up to blah, 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 up to 99. So in the first loop, I is going to be 0. In the second loop, I is going to be 1. And the last loop is going to be 99. So, and you have to do colon, and a colon at the end. And then you have a little indentation, which is important. And then we're going to say, hey, y. And we're going to say, hey, whatever the value of I is, if it's 0, it's going to be the first element. And we want to say, hey, we want that first element, I. Okay? And what number is it going to be? Well, we want it to count up. We'll get to that in just a second. But let's just say it's 5. Okay? And then in the next loop, I will become 1, which grabs this one, and it becomes 5 as well. So let's reprint. Let's get rid of the print y up here. Okay? Hello, folks. I see you in the YouTube chat. Thanks for stopping by. Okay? All right. And so at the end, then so if you want it to be outside the loop, notice how when I'm here and I hit enter, I am still indented, right? So anything I write in here is still going to be in the loop. So if I say print, hey there, print, hey there, it's going to print it 100 times, hey there. But if I get rid of that indentation, it'll just print it once. I'll show you. Hey, look, hey there. If I put it in the loop, hey there. Right? So we don't need hey there. I'm just going to get rid of this line. The way I quickly get rid of lines is I use the home and end key liberally. Okay? End takes your cursor to the end of the line. Home gets to the beginning of the line. So if I hit shift end, it highlights everything, and I hit delete, it's gone. Okay? Now this code should give me 5 in all of those different elements of the array. Okay? So if I print y, I should see that. Voila, 100 5s. Okay? All right. So got 100 5s, and so now instead we want to count it up from 1 to 100. So since I is already counting up, why not make it I instead of 5? And the I should count up with everything else. So if I run it again, can you do it from 1 to 100? You can, but then it'll go from 1 to 99, my friend. Okay, remember, it'll stop at 99. So if you want what you would, that's what I see in the chat. So here, if I run it, 0, 1, 2, 3, up to 99. Again, we want it to count from 1 to 100. So one way to do that is getting a question. Yep. Yeah. Mm-hmm. Yep. Mm-hmm. Well, that's okay. So the question is that, if we go back to the other syntax for making this work, where it creates the double brackets, this code no longer works. And there's a good reason for that. That'll take a second to explain. Is it okay if we do that a little bit after this and just do it this way for now? Sounds good. Thank you for the question. That's and feel free to just jump in. You don't have to wait. I might not see your hand raised while I'm looking at the screen. So feel free to jump in with a question in my audio. Thank you very much. Cool. YouTube, you can't hear, I'm getting some questions in the chat in my ear. So, okay. So here we got that. So anyway, so if we want this count instead of from 0 to 99, we can do 1 to 100 by saying, hey, make it I plus 1. So the first element, 0, will get added 1, and this becomes 1 all the way up to 100. Run it. Boom. Great. Awesome. It works, right? So we count from 1 to 100. Perfect. Now, let's look at what this exact question that the student brought up. And if we go back to the other version, when we said 1, 100. Now, let's run it. Broke itself. Okay. Now, the reason it breaks itself is because this is no longer just a line of numbers where you can say, hey, I just want the first one or the 10th one or the 30th one, right? You have a block of numbers. You have to tell it what row you want, and then what column you want. Okay, you want to tell both of those things. So you have to tell it, I want the very first row. So you might say, oh, the first row, comma, I. And then you realize you made a horrible mistake, because what does Python start counting as first? Goose egg, 0. 0, comma, I. It's because and anyone who's done linear algebra, anyone who has taken a course with a matrix in it, the row comes first, the column comes second. Let's try running it now. Voila. Okay. Because we have now made this a matrix with 1 row and 100 columns, we got to tell it which row and which column. Okay. Right. So now, right, I plus 1. Oh, and we have a person in the chat who told me I plus 1 is the answer, right? So great. That works great. I'm just going to go back to the other syntax. When I say syntax, I mean it's just type of writing. Think of it as type of writing. So it's just 100. We no longer need this 0 comma, and it should all go back to where it came from. How can we possibly finish with guerrilla code with only 15 minutes left? Well, just you watch, my friends. Okay, so we can use. Why do we do these arrays first? Because we're going to need these arrays for plotting. For the other element of what we need, you can see this plotting. We want to be able to draw the scene, right? So we want to be able to draw that scene. So let's go back into our code and start drawing. And the way we need to draw, let me pull this up here. We have to use this library we talked about called matplotlib, okay? And we use a very similar syntax or way of writing to get matplotlib as we did NumPy right here. So we want to import it. It's a library. It's a bunch of tools that we have at our disposal. So we have to import it. I'm putting it with the other import with NumPy up here. So they both run one after the other together. I say import matplotlib. Now this one's a little bit more complicated because matplotlib has a ton of stuff in it. And what we want is the ability to plot in Python, or what it calls pyplot, okay? .pyplot, okay? Right. So this should give us our plotting commands that we need, all right? Now, again, we don't want to have to type out matplotlib.pyplot anytime we want to use the commands that this gives us. So we give it an alias. We give it another kind of name, okay? We say as PLT. So it's a very shortened version of the word plot. So now we can just say plt dot plot. Okay, so let's do plt dot plot. So now I'm going to rerun. I'm going to run this import. So now it is imported. And if you ever want, you can always run everything. There's nothing stopping you. This code's not very complicated, right? But so we ran the import. I ran it with the little arrow. Okay. And now I'm going to go down below. I'm going to create a new piece of code here. We're going to hashtag plot a line. Okay. So the way that you want to plot something in PyPlot is you want to say PLT, this alias we gave for our plotting commands, dot plot. And what you want to do is give it data in the horizontal axis and data in the vertical axis. Okay, and let me show you what I mean. I'm going to go over back to the board. Okay, we would say PLT dot plot and X points. That's just and Y points. There are other things you can add, but this is, again, the absolute basics, so we can keep it in about an hour. Okay. So what that means is that let's say we have a plot with X and Y. All right. And we wanted to plot a line that's made up of points like this. Okay. Each of these points has an X coordinate and a Y coordinate. So let's just say that this here, that's 1, 1. And this here is 2, 2. And this is 3, 2, etc. Right? And let's just keep going. This is 4, 2. And this is 5, 1. It's a bit of a skewed plot right there. Okay? Right? So what are your X points? So your X points would be a list of this number, 1, 2, 3, 4, 5, right? And your Y point, so we say, hey, it's 1, 2, 3, 4, 5. Okay. Now Y points are, of course, the other number, the second number, 1, 2, 2, 2, 1. Okay. 1, 2, 2, 2, 1. Okay. So in the code, okay, we want to create a NumPy array that has 1, 2, 3, 4, 5 and 1, 2, 2, 2, 1, 2, 2, 2, 1 in there. Okay, we can do this. We can do this by hand really quickly. We can say that, hey, we want our X points, and we can call it anything. We can call it just XP, right? Is equal to NP array, open parenthesis, open bracket, 1, 2, 3, 4, 5, separated by commas. And your Y points, YP, is equal to NP dot array, open parenthesis, to say that this goes inside of an array. Open bracket, so it says, so it goes into that row of the array, and it's 1, 2, 2, 2, 1. Okay? All right. Seeing some questions in the chat. Just do blah, blah, blah. Hey, Christian. All right. Oh, I'm seeing some questions about virtual environments. Great question about virtual environments. It's gonna be a little outside of the scope today. Virtual environments are great. We're happy to talk more about that in a future thing. We're gonna try to keep this reasonably short, but basically things get a little bit more complicated when you want to do this on your own computer. Not necessarily that complicated, but there are good and bad ways to run Python on your computer. And a typical way you want to run Python is something called a virtual environment. So that way you can store things like NumPy in a smart way, so you always have access to it. Anyway, that's a little bit outside of scope. That's a great question. Fantastic question. So we want to plot something, XP, our X points, comma, YP. All right. And let's run it. Oh, look, right there. It plotted it. I'm actually a little surprised. Because what you typically need to do is say plt dot show, open close. There you go. Do we need it? Show. So typically you need to plot it, and when you're done plotting, you say, I want to show the plot. So you say plt, your plot, you want to show it. You put a little open close there, and what that means is that this is a function that it needs to, this is a command it needs to run, but it has nothing that it needs to be told to do, so you just, it's empty in between, okay? And look, there's those are the data points that I put in there, and I drew them as a line, okay? And you can change the properties to make it points instead of lines, or all kinds of things you can do in PyPlot, but this is basically those are the points that I put in there, right? So you have the x-axis, you have the y-axis, great. All right, so awesome. So now what this means is that as long as we give it x points in an array and y points in an array, it can plot whatever we want. It's pretty cool. So let's do something simple. Let's plot a circle, okay? And this might require just a little bit of trigonometry, okay? So just a little primer. So if you wanted to plot like a circle that we draw with points, okay? All you need to do is create a bunch of x points and y points that go around in a circle. Okay? All right. So in order to do that, we need all those different points in a circle. And if you recall, there's something called the unit circle, where all of your x points are going to be equal to some radius times cosine of some angle theta, where this is in radians, okay? And y is some radius times sine of theta, and that theta is in radians, okay? So we can use this to draw a circle. So let's make a new piece of code to draw a circle. There's a few things we're going to need to be able to do. Okay. All right. So I'm going to make a new block of code. We're going to draw a circle. Okay. And so we need to make we make an array of points, my friends, that has a bunch of different angles around the circle. Now, there are 2 pi radians in a circle. 2 pi radians in a circle. We're going to count from 0 up to almost 2 pi, up to 2 pi, okay? And then we're going to want to get an array of points that has x in for x and y, okay? And for that, we have to do, so let's create an angle. So we're going to an array of angles. So we're going to count up from some small number 0 up to 2 pi, which is approximately 12. Okay. So what is a good way to do that? So we're going to say that theta is equal to np dot linspace. Okay. Linspace is a command where you can give it a range of numbers. Okay. And so let's say from 0 to 10. And you can say, I want all the numbers between 0 and 10, but I want 30 of them. So let's try that. 0, 10, 30. I'm going to print theta. See if that works. Perfect. Here. Starts at 0, ends at 10, and I want 30 numbers. And if I count them all up, there's 30 numbers. How is that handy? Well, I can say, hey, I want to have numbers between 0 and 2 pi. There are 2 pi radians in a circle. We learned that in school, right? So that's approximately 12, right? And I want 100 of them, right? And you're like, okay, there we go. And you might say, 12 is not exactly 2 times pi. Sorry, 6. Sorry, 6 is 2 times pi. 6 is not approximately 2 times pi. You're right. How do we get exactly pi? Or at least as close to pi as we have. You could say 2 times pi, but it yells at you. In order to use pi, you have to actually say np dot pi. And this is the times symbol. That's how you do multiplication in Python. I didn't cover that. np times pi. right? We're going to go a little over in order to get a little bit of the game shooting here, okay? Yeah, lots of questions about managing packages in Python. Creating a virtual environment, pip installs for another time. We're gonna thank you for those questions. You put them in the chat. I just won't get to them today, but those are things I can cover in a future stream. Thank you, M. Peterson in the chat. All right, so this should work. So because pi is a number that is stored inside of numpy, np. Okay, so let's run that. Voila, look at that. It's an array which has numbers all the way from 0 to 2 pi. And now we can say, hey, friends, we want our x points to now be this number r times cosine, and we'll assume r is 1, so we'll say 1 times the cosine of theta, right? Let's try running it. It's going to yell at us. It's going to yell at us because cosine is not a defined function. It is a function defined inside of numpy, which, what does that mean, friends? Say np dot cosine, because it's stored inside of numpy. Okay, so this should work. All right, I'm going to get rid of this print. We no longer need it. I'm going to get rid of the space. We no longer need it. Our y points are going to be 1 times np dot sine. We get the sine function from trigonometry, okay, times theta. Okay, now we should have x points and y points for the whole circle stored. Now, if we want to plot, let's say plt dot plot x points and y points, and plot dot show, open close parenthesis. Run it. Look at that. That's a circle. It's a little squished just because the axes are squished. That's all, but it's drawing a circle. Let me zoom out a touch so you can see the circle a little better here, right? Okay. So we can, any series of x and y points we want to draw, we can draw using the plot command. That's simple, right? Okay. So now let's get to the gorillas part. Okay. One of the last things that we need is the ability to take an input from the user. And there are lots of ways to do this. We're going to do, well, I guess we got to do the math as well. The inputs from the user, we're going to do this the easy way. We're going to have the user type in a number. So, and that has a very, very simple command that we're going to use. It's called input. It's really simple. So let's go back to the code. So we're going to input we're going to have a new block of code. So we're going to try inputs from the user. Okay. Okay. So we're going to get inputs from the user. So we're going to say x is equal to input, open close, and we'll see what happens. Or let's just choose a different letter. Let's try a is equal to input. Oh, look. It gives me a little thing I can type in. 50. Enter. And a and 50 comes out. Nice. I could say print a times 10 and run it again. Hey, what's the number, friends? It's 50. Enter. Oh, sorry, I guess it's a text string. Ooh. This is a glitch I didn't anticipate. Sorry. We'll do print a. All right. Okay. So we can take in an input. We might not have time for this today, but this is taking in it's taking in a string. You can type in something like that. So we'll cover that in a bit. Let's instead just do the throw. Let's try to throw the banana. Okay. And we're going to do this using just a little bit of physics, okay? It's a little bit of kinematics, as we call it. So let's just move ahead for the sake of time, okay? So we won't have time to do the whole loop of the game. But let's just try just one throw, okay? So we're going to do one throw of a banana plotted on the screen. Yeah, thanks for the thing. So to be clear, I can actually answer this really quickly. My students who do a lot of the, there's some people in the chat asking about virtual environments, and this goes for everyone in the class and outside, in the outside world. My students who do a lot of Python development absolutely recommend using a virtual environment while they will do pip installs, PIP, and you create virtual environments, VENVs, for everything. all the time. That is like their standard operating procedure. That's those are my students that are developing code like for our research projects. So I recommend that because they recommend that to me as their workflow. So, all right, moving on. So let's do one throw of the banana. Okay, what are we going to need for that? Okay, I'm going to go onto my screen again. This will be the last thing we cover today. We're going to plot a throw of the banana. All right. Okay, so plot a throw of the banana. Whoa, 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 whoa. Okay, so we're going to throw a banana. We're going to ask for an angle and a speed. Okay, so now we learned from physics that if you have that if you want to know the position of something, let's just say we'll call it y, the position. You have x and y, and you want to know the position of something over time, and it's operating under gravity. Okay, what you need to know is where it starts, y0. So if I'm throwing this pen, which is expensive, so I won't, but it starts at this height. I need to know what height it starts at. What height it starts at. I need to know its initial speed in that direction, how fast it's going at that moment. I need to know how much time it has been in the air, t, okay, plus 1/2 times the acceleration of this object. And if this is in the air and it's going up and down, it's accelerating due to gravity, okay? So we'll put the acceleration here as just some a times the time it's been in the air squared, okay? You can get this via calculus. You can get this equation via a lot of different ways, but this is just a simple math for what we call projectile motion. That's how our banana is going to move around. So we're just going to use NumPy's features to compute this. And it's not quite as intuitive as you might expect. Okay. So, so what we're going to need in order to plot this, we're going to need an array. So we're going to need an array of all of the x points and y points for whatever this parabolic throwing trajectory is, given the fact that we have an initial velocity, an initial position, and an acceleration, okay? Now, we have movement in two different directions, in the x direction and the y direction, so we're going to need two of these equations. I just wrote it for the y direction, okay? Where the acceleration here is gravity. So it's going to be minus g, and g is, we're going to be talking in meters, so it's going to be, g is 9.8 meters per second squared, okay? This v0 we're going to get from the user. We're going to type it in just in a little, we're going to type it in as a variable, okay? How much time it's, how much time it's in the air. We're going to have to try it, but we're going to draw it for a bunch of different times. Okay, so that way we get it here, 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 here. So we get this entire curve. We're going to draw it at time 0, time a little bit, time a little more, time a little more, time a little more, time a little more, etc. Okay, so for y, it's equal to all that stuff up there. For x, it's going to be equal to some initial x position plus some velocity in the x direction. So I'm going to say that's y up here, x here. So it's basically the velocity vertically and the velocity horizontally. They can be different, of course. Okay. Times t plus 1/2 a t squared. And this is in the x direction. But here's the thing. If we ignore air resistance, there is nothing pushing back on it in the x direction. So let's ignore air resistance. So let's do a little thing. Cross this out. This is all 0. There's no air resistance. We can do it with air resistance, just not today. Okay. All right. So we have two equations. We have our x vector, our x array. People in my class will know to call it a vector. Okay. Plus v0x times t. And your y is equal to y0 plus v0y times t minus 1/2 g t squared. The minus because it was minus g inside because we're accelerating downward due to gravity. Okay? All right. So what we're going to do is we're going to create a vector of time points from time 0 with tiny, tiny little increments up to some larger number. We'll say maybe 10 seconds. Okay? And then we're going to create an array of x's and y's to plot. Right now, we'll just put in the velocities of x and y as variables. So let's do that real quickly in the code. Let's just say that let's say that x0, our initial x position, is 0. Initial x position. Y0 is going to be 0 as well. With the initial y position. All right. V0x. V0x, the initial x velocity. Technically, we should be doing in units. So let's say these are meters. This is in meters. So I'm going a little quickly with the typing, but you all can follow along. Let's just say it's 3 meters per second. This is just in meters per second. Then V0y, these are zeros, not O's. Initially going up high, let's go 3 meters per second vertically, okay? And G, we're going to define as 9.8. This is gravity, and that's in meters per second squared. Okay, simple physics. You will learn this in high school. Okay, so now we need to create a time array. And we're almost done here. All right, create a time array. So we're going to say T is a time array, and it needs to be a bunch of different numbers between 0 and let's just say 10 seconds for now. So we will say, hey, np.linspace, we want from 0 to 10 seconds, okay? And we want it to count in between those with like, I don't know, 1,000 different points, okay? All right, why a big number like 1,000? Because then that way, when you're looking at this plot right here, it's a nice smooth plot of lots of different points as opposed to like something blocky, like right, like we drew before. So, right. So, now we're going to compute our trajectories in x and y. So x is going to be equal to. We'll keep up our math up here. So x is going to be equal to x0 plus v0x times t. And we'll see if that works. Let's try it out. See if it yells at us. Oh, it didn't yell at us. How nice. How nice. In fact, let's print x to make sure everything's working nicely. Cool. There we go. There's x. I'm plotting a lot of stuff. And x, you'll see it starts at 0. That's good. That's good. Then after a little bit of time, it's gone 0.03 meters or 3 centimeters. And after a little more time, it's gone 6 centimeters, etc. Look at all those points until eventually it's gone. After 10 seconds, it's gone, surprise, 30 meters. It's going 3 meters per second for 10 seconds. Therefore, it's going to go 30 meters that way, assuming it doesn't hit the ground somehow. Okay? Now, let's get rid of that print right there. Now let's do y. It's equal to y0 plus v0y times t plus, and you're going to say 1/2. Generally speaking, I like to just write 0.5. You could also say 1/2, 1 divided by 2, times, and it's a minus right here, right? The minus mg squared, so minus 1/2 g times t to the second power. Now, spoilers, okay? This might not work as intended quite yet. There's a very specific reason. This is how you do powers, typically in Python and many, many, many programming languages. But there's a little bit of a catch when it comes to arrays in Python, okay? This is not going to work as intended, all right? Because if you want to raise every element in the array to itself, you have to do a slightly different calculation. You have to say, I want to take it to the power. I want to take t to the power of 2. Why is that? because these lists of numbers in math, they have a name. They're called vectors. And vectors and matrices have weird rules when you multiply them. It's for good reason, but they're weird. And NP, NumPy, thinks you're trying to do that when you try to square it or try to multipy it. So you got to do something like NP.power, and this will raise it to the power of 2. Okay? So let's take these two vectors, these two arrays, and let's plot them. Plot the trajectory. Okay? We're going to say NP.plot. We're going to give it X, and we're going to give it Y. And then we're going to say, sorry, not NP.plot, PLT.plot. I apologize. I'm trying to plot. And then PLT.show, open, close, to show we want to plot it. Let's throw it. Oop, what did I screw up? Sorry, that's not a comma. That's a period. That's a typo. Okay. There we go. We threw it off a building, it looks like. It never stops because we never tell it to hit the ground. But that's a parabolic trajectory, okay? So I think 10 seconds is too long. So let's change it from 10 seconds to 3 seconds. And let's throw it a little higher in the air. Let's throw it at a velocity of 10 meters per second in the air for 0. We changed this to 10, and we changed this to 3. Now let's throw it again. I ran the code. Oh, and voila. Hey, look, a little parabolic trajectory. Now, we did not get through all the looping of this to take in the player commands to, in order to ask the player for what angle they want to throw it and check if it hits the gorilla. That's a couple of extra steps. It just requires doing what we call an if statement. If statements are not complicated. All you would need to say is one way to do an if statement is you would say, if 1 is greater than 2, sorry, if 1 is greater than 2, print yes. Did I do that wrong? I did it wrong. Anyway, it's not greater than 2. We did not print yes. 2 is greater than 1, we print yes. It's that time of night. Hey, look, yes. If that's true, yes. Else, print no. Okay? So we want to use if statements to say, did you hit the gorilla? And that's actually going to be a little bit more tricky than you might think to check if it hits the gorilla. But we're not doing that today. And the input command is how you get the number from the user, but we have to turn it into a number first. Right now, it thinks it's actually just the numbers on the letters on the keyboard 100, and not a number. So we got to turn it into a number. That's not too hard. So, but there, we did parabolic trajectories. You plotted that. Okay, that's the basic elements of Python, which is a little bit of physics mixed in for throwing the gorilla, for throwing the banana. Look, banana, boom, thrown. Okay. So, anything anyone needs to see here? This is just a little test if statement. Okay. Any other questions before we finish up today? Let's see. I see a few in the chat here. I got a very nice comment. Thank you from the Zoom. I'm glad you think that I rock. Great. All right. We got a few questions here. Interesting that NumPy doesn't provide higher level physics geometry helpers, things like projectile motion. I guess they're intentionally focused on fast array operations and math primitives. I agree. And you don't want to put too many things in NumPy, too many things in a package that are not really that relevant. But there are packages like SciPy, okay, for like scientific computing. I'm not sure I don't know if they have projectile motion built into it, but they have all kinds of important mathematical and computational tools that we will ultimately use as part of the machine learning course. And again, by the way, anyone watching, thank you for tuning in. Super cool. Thanks. And you can go through the YouTube channel and find the other live streams of the other courses so far. We've done 2 lectures for each of the classes. One of them still needs to be uploaded, but you can find the playlist that's publicly available on the YouTube channel right here. Or you can subscribe if you are so inclined. You'll get alerted when there's new lectures. Feel free to pop in for any of the lectures. If there's an interesting question, hopefully the TA will tell me, and if I can get to it, I will during the lecture. All right. Would I define a hitbox for the gorilla and then check if the line falls in the hitbox? How would we know if it hits the gorilla? Great question. Yes, that is what I would do. Okay. We also didn't cover animations here. Animations are a little bit trickier in this environment that we're looking in, but I love doing animations. I love doing animations. You'll be seeing us doing animations tomorrow in my first class at 9:30 a.m. That's using a different language called MATLAB. It's in my controls class. So you might not have MATLAB on your computer. It's more of a specialty software for engineers, but we'll be animating tomorrow. And that should be a good time. And Morgan Mac, thanks for stopping by. Hey, everyone. Thanks for stopping by. All right, I got a question from Joaquin. Do we need to know how classes work for this class? And by classes, he means this idea in programming that you have a class, a type of object, okay? The answer is not in a lot of detail. Here's the thing. You just used classes with what we did right here. Right here, this thing right here, we used classes, okay? We used a plotting class to create this plotting object .plt. Plt.plot. Okay? We're using classes already. Now, do you need to be able to build your own class from scratch? No, that is not a requirement of this class. But you will be using object-oriented programming for which classes, sorry, I'm mixing up classes in two different contexts, okay? From which classes come from, we'll just use them. We just learn how to use them, the syntax from it, and then voila, there you go. So that's great. But if you do want to know how to use objects and classes more thoroughly, absolutely go for it. It's not that complicated, okay? Does that answer your question, Joaquin? All right, any other questions before we go? Thanks, Morgan Mac. Great to have you all. We'll do any last minute questions here, and we'll wrap up, okay? I'll do a quick scroll through. I'll find a way to post this, some kind of way to post this so that people can find this code online. Again, it's not very sophisticated. We just nailed it and hammered it out. But at the same time, it did what we needed it to do. We were able to throw a banana. There, it starts there at 0, 0. Woo! Throw the banana. Thanks very much for the question. I'll assume that we're about to wrap up. Thank you all for coming. I know it's been a late night, and oh, someone sent me a banana emoji. Right on. And I'll see many of you for classes tomorrow. 9:30 a.m. is Optimal Controls. I've sent out a Zoom link for the class. You will see it on the YouTube page for the live stream. And at 12:30 p.m., again, all Eastern time, will be Machine Learning. I'll look forward to seeing you all. You all have the Zoom link, so you can join over Zoom and talk in my ears. YouTube, you can enjoy that on the live stream as well, assuming